Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last session we did expressions, and now in this session we are going to talk about exception handling. Let's get to the objectives. Let's talk about types of Python exceptions. Handling them with try, except finally. How to trigger them with raise. How to define new ones. And how to implement exception handling. Finally, let's give a working example with regular expressions. So, what are Python exceptions? Well, when something bad happens, we need to know about it. So, Python lets us know via an interface called an exception. And you can see a whole list of them at python.org. But, let's have a look. Built-in exceptions. We have base classes, the base exception, regular exception, and a couple other ones. Look up here. And the other ones are based on those exceptions. So we have assertion error, attribute error, end of file, floating point error, general exit. You can't import something, maybe because its module's not found. You try to index something that's not in the list or not in a dict. Control C, you'll get that. Oh, you don't want to get that. And file not found and different things. Those are the basic exceptions. So it's good to work with Python standard ones because other programmers will recognize what you're doing easier, and it's easier to integrate with other libraries, and also you won't have to write them. But like we said, you can create your own. So exceptions are the main way to handle errors in Python. If there is an error in a program, it dumps a stack trace and an error message, and those error messages are simple uncaught exceptions. So you implement exception handling with the try statement. So you issue the try statement, and then a block begins because you have your colon. Block is indented, one or more spaces. Standard is 4 spaces. Then you list all of your lines where you think you're going to get an error, and then you list all of the exceptions you think may trigger it, may get triggered by this code here. So, for example, this exception, IO error, will get triggered if there's an input-output problem. For example, the file doesn't exist. So if that error is triggered, then you'll print a message. You can do anything, print anything you want here. The message is, the error is caught in this variable E, so you can print that out as well. And if nothing else happens, nothing bad happens, you can use your variable that you defined, or you can do anything else. And finally is used, this code will always execute, even if this causes perhaps this causes an operating system error, or maybe this causes a sig fault in your execution runtime. This code will always be executed. That's the theory. So let's try this and see how it works. let's run. Let's get a little closer. Let's run Python. Let's run Python. Let's type in our code, see what happens. Whoa. So, we could not, it says could not open the file, which is curiously the same thing we have here. And then after could not open file, it prints our error that we caught. Could not open file. And then here's our error we got from Python. Error number 2, no such file or directory. So it couldn't find a file called file name. And then we see executing finally. So even though we got an error, it still executed this. This code never got executed. So let's try to, well, we can create a file called finally, or we can let's say open file name for writing, and then we can write line we are getting it. No object write line. Oh, what language am I talking about here? Right? A bytes object is required, not a string. So 17 bytes written. And now, let's try to execute our code. See what happens. Well, it looks like we opened our file, but this time we did not get an exception. Instead, it looks like it executed the else, and it actually printed a line. Huh. Stripped off the new line character at the end. Well, I didn't even have one actually. So you recognize the for statement. The for loop, it's a loop actually, it'll go for each line inside of our file handler we opened up. And then finally it printed executing finally, of course. Huh, it worked. Triggering exceptions with raise. So you can use the raise keyword. And looking briefly here, this is a function, this is a function, so the main line starts here at this if statement way at the bottom. So if this is standard, you don't have to know what this means, but it's Python we've already learned as an if statement. The name is if you're running the code not in a library, then you'll be running the main. The name will be main that you're running. So if it is, then we run this main. So this is how you get around executing code in a module if it's just being imported. So only if you are running it do you want to execute this main code. So that's what's going to happen. That what I just said has to do with module importing, which you don't really have to know yet. We haven't covered that yet. But we're going to try to read file on xlines.txt, and then we're going to print the same thing we just did, basically, and capture exceptions. And finally, so in this read file function we've defined down here, we accept the file name and we say if the file name ends with .txt, then we're good. Otherwise, we want to raise a value error and tell the user, which may be another program. If this is a library, we may want to tell the user must end with .txt. So like we said, we can define our own exceptions. We inherit from the base class exception, which we saw from python.org. And we can also, multiple inheritance and create our other exceptions. So we want to implement those. We can define a function here. My function. We check an error condition and we raise my input error if it's true. Or maybe we want to check for a different error and we could raise another error. If we don't get either of these two errors, we can return success to the user. So if we're going to call my function, right, there's our definition. Over here, we can find out how to call it. And so we can try to print my function, give it some arguments. And if any error condition happens, we may get an exception. Like, for example, my input error. And then we can print that off to the user. The last thing we'll talk about is working with regular expressions. And as an example for exception handling. Regular expressions are a powerful language for matching text patterns. We saw them in a previous session. The module RE provides full support for regular expressions in Python, and it raises the exception re.error if an error happens by compiling or using a regular expression. In Python, a regular expression search is typically written as the variable equals the re.search, and you give it a pattern and a string to look in. So let's take an example. If we have this string, let's try to match using this pattern, which is WORD colon followed by 3 words. All right. So if we get an error, we can raise the error to re-raise it and then make sure we capture. We could massage it if we wanted to, or else we check if we got a match, because maybe it's not an error, but it just didn't match. For example, we could get an exception if this was not a string. Perhaps it was an integer. We get integer error or type error. So if everything's fine, no exceptions, this could be blank if it didn't find this. Regular expression didn't match. Well, then match would be none. So none evaluates the Boolean false, so it would not print found match cube. Let's try this code and see what happens. All right. So it found the word cat. Right. 3 letters. Word letters. Just letters. The assignment is to use try, except finally, and raise in a program. that's it for today. Next time we're going to come back with using the string object. And we're getting close to the end of this class. Only a few more left. So join us next time. That's it. Thanks, guys.